Today our topic is spectrum analyzer. Previous class we have discussed about wave analyzer. There are two type of wave analyzer, heterodyne wave analyzer and frequency type wave analyzer, heterodyne type. And then we discuss about the harmonic distortion. So first we have discussed today is spectrum analyzer. So why we use spectrum analyzer? The most common way of observing signal is to display them on an oscilloscope with time at the x-axis, means amplitude of the signal versus time, and this is for time domain. And to display the signal in frequency domain we use spectrum analyzer. So spectrum analyzer provides a calibrated graphical display on its CRT, means cathode ray tube, with frequency on the horizontal axis and amplitude voltage on the vertical axis. So horizontal axis we get the frequency, and vertical axis if we take the amplitude or the voltage. Displayed on the vertical axis, again these coordinates are sinusoidal component which input signal is composed. The height represents the absolute magnitude, horizontal location represents the frequency. So if we take the display of a frequency spectrum over a given frequency band, the spectrum analyzer uses parallel filter bank or a sweep frequency technique. In parallel filter bank analyzer, the frequency range is covered with a series of filters whose central frequency and bandwidth are so selected that they are overlap each other. Means if we take, this is the input and we use filter, we take the output. There we use filter and take the corresponding output. This is the parallel filter bank analyzer. If we take the output, we see the output is like on CRT display. So audio analyzer, we have 32 of the filters is covering 1/3 of the octave. For a wide frequency resolution, particularly RF or microwave signal, sweep technique is preferred. And if we see the graph, then we see the graph is like that, overlapping each other. This is an parallel filters, time x-axis, amplitude in the y-axis. So basic spectrum analyzer use basic spectrum analyzer. If we draw the what is the basic spectrum analyzer using sweep receiver design. So what we see, if we see that there is a sawtooth waveform which voltage will drive the horizontal axis element of the scope, and the sawtooth voltage frequency is controlled voltage tune oscillator. If we see the spectrum analyzer circuit, then we see that there is a input is passed through a mixer, then there is IF amplifier, means interfrequency amplifier, then it's go to the detector and video amplifier, there is a spectrum CRT skin output with display, in mixer we take that voltage tune oscillator. then sawtooth generator, and this is go to the another CRT scheme. So if we input wave signal AM, we see that amplitude versus time, then the graph will be time x-axis, y-axis we take the amplitude, then the waveform will be like that. This is for F, twice F, and if we take for F means single frequency, and if we display the spectrum, then we see, then this is for A1 and this is for amplitude 2 A2 for frequency F, this is for twice F. This is the graph for frequency versus amplitude. So what happened here for the circuit? The circuit is input is first passed through an oscillator, and sawtooth generator provides the waveform. Oscillator sweep from a minimum to a maximum, frequency minimum if F min and F max mean the frequency maximum at the returning oscillator. It's with the frequency component of the input signal recurring rate, it which the frequency component of the input signal and produce the IF, where the frequency component is met during its sweep. The frequency component and voltage tune oscillator frequency beat together to produce different frequency, that is IF means intermediate frequency. The intermediate frequency corresponding to component amplifier and detected if necessary, then applied to the vertical plate of the CRO produce the display. So its display is shown in the CRO and the corresponding waveform we see. So whatever we use the basic spectrum analyzer we have shown here. If we take an radio frequency wave analyzer means RF spectrum analyzer. So practical example is study RF spectrum analyzer microwave instrument. Microwave instrument have a frequency horizontal axis can be a 2 to 3 gigahertz for a broad and 30 narrow frequency, then highly magnified, then signal of microwave is generated individually. So how we see that a RF spectrum analyzer? What is the picture of a RF spectrum analyzer? So there is a input. Suppose we given 0 to 1 gigahertz, then is passed to a low pass filter LPA. Then it's mixers, then IF intermediate amplifier. Suppose it's give 2 gigahertz, then same as detector, and there is mixer, there is a voltage tune amplifier, local oscillator which give 2 to 3 gigahertz, there is a sweep generator, and then we take the CRO skin, we take the output. So frequency range covered, the instrument is 1 megahertz to 40 gigahertz, and the spectrum analyzer covering the range 500 kilohertz to 1 gigahertz. So the input signal is passed fixed to the mixer, which is driven by a local oscillator. It is seen that, and the oscillator is linearly tunable electrically 2 to 3 gigahertz. The mixer provides the two signal at the output proportional to the amplitude and input signal, but the frequency which are sum and difference of the input signal are local oscillator frequency. The IF amplifier means intermediate frequency amplifier is tuned around 2 gigahertz, which we see in the figure that it is 2 gigahertz. So local oscillator is tuned 2 to 3 gigahertz, So output separate frequency difference between the 2 gigahertz, which is converted to intermediate frequency, and passed through a IF frequency amplifier, and gate rectifier produced a vertical screen on the CRT vertical axis. And if we take the observation sawtooth signal, the local oscillator sweep 2 to 3 gigahertz tuning the spectrum analyzer sweep frequency, which linearly 0 to 1 gigahertz. The sawtooth scanning is applied to the horizontal plate of the CRT. This is first one is vertical axis, this is gone to the horizontal axis. So two signal are mixed spectrum analyzer 4 to 5 gigahertz. So a low pass filter of cutoff frequency 1 gigahertz is input suppress. This suppress the signal. So spectrum analyzer are widely used where we use radar or biomedical field. These are the application of the radio spectrum analyzer. So we see that spectrum analyzer we use for analysis of spectrum is there are the two components, x-axis and y-axis. X-axis is we take the time, and the y-axis we take the amplitude. Corresponding spectrum we have to calculate. How we calculate using the spectrum analyzer we have discussed. It will discuss also in radio frequency amplifier. So these are the application of the spectrum analyzer.